See this one, applications of derivatives, exercise 2.1 second. We have written up to this. Now just write down when x is 4, because we haven't written x1. So just write when x is 4. What is y? It is root 1, but by root we mean positive root. So y is 1 only. So there is only one point, required point for 1. Okay. So I will read the sum. A particle moves along the curve 6y equal to x cube plus 2. Find the points on the curve at which y coordinate is changing 8 times as fast as x coordinate. So you have to write in the beginning. Write down. I'll dictate the first part of the solution. Let p x1 y1. Write the solution for sum number 4. Let p x1 y1 be the point on the curve, 6y equal to x cube plus 2, 6y equal to x cube plus 2, whose y coordinate is changing, 8 times as fast as x coordinate, that is, tell me what is given. Y coordinate will change at what rate? dy dt. So dy dt at that point, say p, we have said that point is p, is what? It is 8 times dx dt at p. This is not at all difficult. Today's sums just A or B group sums, not difficult sums. So this is number 1. Now differentiate the given relation. Write down 6y equal to x cube plus 2 with respect to t. Therefore 6, what is derivative of y with respect to t? dy dt. Now what is derivative of x cube? It is 3x square followed by dx dt. What is derivative of 2? Derivative of 2 is nothing but 0, it being constant. Okay. Now after this I can say therefore 6 dy dt at p is 3 x1 square okay, but from 1 tell me what is dy dt at x equal to p? Substitute. Therefore I could have cancelled 3, but as I haven't, I will write this as 6 into 8 dx dt, okay, at p is what? 3x1 square dx dt at p. Simple. Now we can cancel this. Dx dt is present in both the cases, or both the sides rather. Therefore I get equation x1 square. Tell me what is x1 square? X1 square will be 16. Therefore x1 is nothing but plus or minus 4. Now you will ask me, sir, why to consider plus minus 4 here? Because the equation contains cube, right? So cube of 1 is 1 and cube of minus 1 is minus 1. So no two numbers have the same cube. But in case of square, two different numbers can have the same square. Minus 2 ka square 4, 2 ka square also 4. So in this case, that question doesn't arise. Okay. Now consider these two values. When x1 is 4, x1 equal to 4 gives what? See, the point lies on the curve. So I can say 6y1 equal to x cube plus 2, that is 4 cube plus 2. Tell me what is 4 cube plus 2? It is nothing but 66. Therefore, y1 is 11. Therefore, point is 4, 11. Okay. Yes, plus or minus, I have considered both, but I have to consider them one by one, right? Then x1 equal to minus 4 gives 6y1 equal to minus 4 cube plus 2. Now it is minus 4 cube minus 64 plus 2 is minus 62. So tell me what is y1 from this. And therefore y1 is minus 62 upon 6, that is minus 31 upon 3. Therefore I will say p dash, because both points cannot have the same name. So first is p, second is p dash. So which is the second point? It is minus 4 minus 31 upon 3. Okay, so this is the answer. Write down. We are solving sum number 5. Let r be the radius. Write the solution. Let r be the radius and S, capital S, be the surface area of the soap bubble. Surface area of the soap bubble at any time t. At any time t. Then yes, write the formula. Capital S equal to what? 4 pi r square. Differentiating with respect to t. Differentiating with respect to t. So what is ds dt? 4 pi is constant. What is derivative of r square? 2r dr dt. So effectively it is what? 8 pi r dr dt. Now substitute the values. We are given the values. Here, what is dr dt? Substitute that. Dr dt is, I think, 0.02 centimeter per second. Observe the unit. And r is given to be 5 centimeter. This is simple one. Therefore, ds dt comes out to be, tell me, 8 pi as it is, multiplied by 5 multiplied by 0.02. See, you are not supposed to substitute the value of pi because it is not helping in simplification. Had it been 7, I would have written pi as 22 by 7. So 7 gets cancelled. Okay. So I think it is 0.8 pi. Now unit is important. So what will be the unit? Centimeter square, because it's area per second. Okay. So this is the answer. I hope you understood this. Okay. What is the sum? The surface area of a spherical balloon is increasing at the rate of 2 centimeters square per second. At what rate is the volume of the balloon increasing when the radius of the balloon is 6 centimeter? Solution, write down. Let R be the radius. Let R be the radius. S be the surface area. S be the surface area. And V be the volume of the spherical balloon. You have to write this in exam. V is the volume of the spherical balloon at any time t. At any time t. Then yes, what is S? 4 pi r square. And what is V? Formula for volume of sphere? 4/3 pi r cube. You have to be careful. 4/3 pi r cube. Therefore, yes, tell me what is ds dt. Write down. I will directly write 8 pi r dr dt. Now from this, what is dr dt? It is nothing but 1 upon 8 pi r ds dt. See why I have written this? Because we are asked at what rate is the volume of the balloon increasing. That is, we have to find dv dt. And what is given? We are given ds dt. Okay. Now, I differentiate volume function. Differentiate volume function. Also, dv dt. Tell me what is dv dt? 4/3 pi is constant. What is derivative of r cube? 3r square dr dt. Now substitute the value of dr dt. So you get relation between whom? dv dt and ds dt. So what is dv dt then? It is nothing but, now if you simplify, then 3 gets cancelled. Okay. So it is just 4 pi r square. And what is dr dt? It is 1 upon 8 pi r ds dt. This is not at all difficult. See, the relation between ds dt and dv dt is to be obtained. Why? Because dv dt is asked and ds dt is given. But in both the cases, the common factor is what? dr dt. You could have taken the ratio also. Same thing. So dv dt comes out to be what? Simplify this. dv dt comes out to be r upon 2 ds dt. I hope you have understood this. Now what is given? Substitute the values. You have to mention that here r is what? See what is r? I think r is 6. So 6 by 2. You have to observe the unit also. What is ds dt? ds dt is nothing but 2 given. So it is 6. But note that it is change in volume. So while writing answer, you have to say centimeter cube per second. Okay. So at what rate the volume of the balloon is increasing? Yes. Avanti, Aditya, Rama, everybody has written the correct answer. Very good. So the volume of the spherical balloon increases at the rate 6 cubic centimeter per second. Good. Now don't wait. If you have finished, I think this is sum number 6. Go for sum number 7. We have to complete this exercise today. Now sum number 7. If each side of an equilateral triangle increases at the rate of root 2 centimeter per second, find the rate of increase of its area when its side of length 3 centimeter. Okay. So write the solution. Let x centimeter be the side of an equilateral triangle. Let x centimeter be the side of an equilateral triangle. Then its area is given by, yes, what is the formula? A equal to, see on the screen, A equal to root 3 upon 4 into x square. Therefore, differentiate dA dt. See, in exam you are supposed to write on differentiating with respect to t. You have to give that much respect. So what is derivative of x square? Not with respect to x, with respect to t. So derivative of x square with respect to x, 2x first, followed by what? Dx dt. Then you have to say we are given this, we are given that, and then substitute. Don't substitute directly. You have to say we are given dx dt root 2 centimeter per second, x equal to 3 centimeter, like that. So this is actually root 3 upon 2. Okay. Now what is x? I think x is 3 centimeter and dx dt is given to be root 2 centimeter per second. Check the answer. It is 3 root 6 upon 2. What will be the unit? Area. So centimeter square per second. You could have written this as what? See, this is 2, which is root 2 root 2. 1 root 2 gets cancelled. So you could have written this as 3 into root of 3 by 2. Same thing. But it is better that we write answer with rational denominator. So 3 root 6 upon 2 centimeter square per second. Now sum number 8. The volume of a sphere increases at the rate of 20 cubic centimeter per second. Find the rate of change of its surface area when its radius is 5 centimeter. Write the solution. Let R be the radius. Let R be the radius. Yes, Karthik, you cannot do that directly. You will lose marks if you write directly. Let R be the radius, S be the surface area, and V be the volume of the sphere. V be the volume of the sphere at any time t. At any time t. See, we already solved one sum of this type. Then S equal to 4 pi r square and V equal to 4/3 pi r cube. Okay. Now here I will write next step on differentiating with respect to t. So ds dt is what? 8 pi r dr dt. And here what is dv dt? It is 4 pi upon 3 constant into 3r square dr dt. Okay, see what I'm doing. So this is 4 pi r square dr dt. Okay, now I will not find value of dr dt, but I will take the ratio. See, one and the same thing. Therefore, ds dt upon dv dt will be what? It will be, see, 8 pi r dr dt. I am taking the ratio upon 4 pi r square dr dt. So if you simplify this, see what you get, dr dt gets cancelled, right? Then I think it is 2 upon r, simply 2 upon r. Okay, but we are interested in ds dt. Therefore, ds dt is nothing but 2 upon r dv dt. One and the same thing. You could have said, sir, ds dt is this. So from this, what is dr dt? 1 upon 8 pi r ds dt, which we had done in the previous sum. And then put value of dr dt in this equation. Same thing. So we have got ds dt equal to what? 2 upon r dv dt. Now, substitute the values. So you have to write this separately actually. We are given dv dt equal to 20 cubic centimeter per second and r equal to 5 centimeter. And then only you can substitute the values. You have to be very careful. In some cases, one is in meter, other is in centimeter. So you have to convert meter into centimeter. So 2 by 5 into 20, which is nothing but 8. But what will be the unit? It is area. So 8 centimeter square per second. Now, sum number 9. The age of a cube is decreasing at the rate of 0.6 centimeter per second. Find the rate at which its volume is decreasing when the age of the cube is 2 centimeter. Simple. Write the solution. Let x be the age of the cube, EDGE age. Let x be the age of the cube and V be the volume at any time t, and V be the volume at any time t. Then, yes, see on the screen, what is volume? V equal to x cube. Then you have to write differentiating both sides with respect to t. Differentiating both sides with respect to t. So dv dt equal to 3x square dx dt. It's a playgroup sum, but will be asked in exam, board exam, for 2 marks. Then you have to say we are given dx dt equal to what? 0.6 centimeter per second. Am I right? Yes. And what is x? X is 2 centimeter. So you have to mention this. Okay. And then only substitute. So this is 3 into 2 square into 0.6. So comes out to be what? It is 7.2. 7.2. But what will be the unit? Its volume. So cubic centimeter per second. Okay. Now the next sum, that is sum number 10. Let me read the sum. A man of height 2 meter walks at uniform speed of 6 kilometer per hour away from a lamp post whose height is 6 meter. Find the rate at which the length of the shadow is increasing. Okay. Now see the diagram. First, let me explain that let OA be the lamp post and PQ be the man. Now PB equal to, we can say, take PB equal to X and this is equal to Y. So PB equal to X is its shadow. And what is OP? OP equal to Y the distance of the man from the lamp post at time t. Do you agree with me? Okay, so start writing. Let OA be the lamp post. Write down. Let OA be the lamp post. PQ the man. PQ the man, comma, PB equal to X. PB equal to X, his shadow, and OP equal to Y, OP equal to Y, the distance of the man, from the lamppost at time t, Now draw the rough sketch. Draw this. I'm sorry. Draw this. Archit, you are absolutely right. Okay, if you have finished drawing this, what is given? dy dt is 6 kilometer per hour. And what is asked? We have to find dx dt, because dx dt is the rate at which shadow is increasing. Write down. This we have to find. Okay. Now, see, to get the relation between dx dt and dy dt, we must first obtain relation between x and y. Now, from the figure, by similarity of triangles, see these two triangles are similar. Which two triangles? ABO and QBP. These triangles are similar. So I can say from the figure, x upon 2 equal to what? X plus y upon 6. Simple. I repeat, from the figure, x upon 2 equal to what? X plus y upon 6. Write down. It is sufficient to write from the figure. You need not say by similarity and all that. From figure, x upon 2 is nothing but x plus y upon 6. Therefore, x equal to x plus y upon 3. Rearrange the terms and tell me how these are related. Therefore, 3x equal to x plus y, that is 2x equal to y. So it is x. Therefore, x is nothing but half y. Now you have to differentiate both sides with respect to t. You have to differentiate with respect to t. Okay. You have to actually write that on differentiating both sides with respect to t. So dx dt is half dy dt. Now dy dt is given. The man is moving away from the lamp post at 6 km per hour. So half into 6. So 3 kilometer per hour. This is the final answer. Right now. Okay, now sum number 11. A man of height 1.5 meter walks towards a lamp post of height 4.5 meter at the rate of 3 by 4 meter per second. Find the rate at which his shadow is shortening, and second, the tip of the shadow is moving. So first draw the diagram. Draw the diagram. Now initial part of the solution will be the same. So I will write that in this fashion. So you have to write the same, like let OA be the lamp post, then PQ be the man, and so on. Right now, write the solution. Okay, if you have finished this, just listen to me. I'll give some time to write. See, you are also asked to find the rate at which tip of the shadow is moving. Let me explain. See, B is the tip of the shadow, right? And it is at a distance of what? X plus Y from the post. So DDT of X plus Y. I repeat, ddt of x plus y, that is dx dt plus dy dt, is the rate at which the tip of the shadow is moving. I hope you are getting this. See, what is dy dt? It is the rate at which the man is moving towards the lamp. What is dx dt? Dx dt is the rate at which his shadow is shortening. But if you add them, then it is the rate at which the tip of the shadow is moving. Okay, because B is at a distance of what? X plus Y. I hope you understood this. Right now. So again, in this case, you have to use the relation from diagram. Right down. X upon, same logic, X upon 1.5 is what? X plus Y upon 4.5. The same thing, yeah. Therefore, in this case also, x equal to half y. So dx dt is half dy dt. So this is nothing but half. What is dy dt? It is given 3 by 4. 3 by 4. So 3 upon 8 meter per second. This is answer of the first part. That is, his shadow is shortening at what rate? 3 upon 8 meter per second. Write down this. Write down this much. Yes, Archit, Aditya, you're absolutely right. Now, write down. B is the tip of the shadow. B is the tip of the shadow. And it is, B is the tip of the shadow. And it is at a distance of x plus y from the post. It is at a distance of x plus y from the post. therefore स्क्रीनवर बघा ddt of x plus y equal to dx dt plus dy dt, derivative of sum of derivative, dx dt plus dy dt is the rate at which the tip of the shadow is moving, is the rate at which the tip of the shadow is moving. Therefore, write down, tip of shadow is moving at, add the values. What is dx dt? What is dx dt? It is 3 upon 8 plus what is dy dt? 3 upon 4. So 9 upon 8 meter per second. This is the answer. Okay. Yes, Rama, you are right. Next sum is sum number 12. A ladder 10-meter long is leaning against a vertical wall. If the bottom of the ladder is pulled horizontally away from the wall at the rate of 1.2 meter per second, find how fast the top of the ladder is sliding down when the bottom is 6 meter away from the wall. Okay. So the diagram will be like this. Suppose AB is the ladder, okay, and I consider this distance as x and this as y, so that I get the relation between x and y. And AB is what? AB is 10. Okay, just draw the rough sketch. Draw the rough sketch. See, I think this sum will be asked for 3 to 4 marks. So if you just do the calculations like x square plus y square is 100. So 2x dx dt plus 2y dy dt equal to 0. And therefore, you won't get full marks for that. You have to draw the diagram first. Okay. Now write down. Let AB be the ladder. Let AB be the ladder in bracket 10 meter bracket complete. Let at time t, let at time t, the end A of the ladder, the end A of the ladder be x meter from the wall, be x meter from the wall, and end B, capital B, be y meter, अतः be y meter from the ground. In right triangle OAB, in right triangle OAB by Pythagoras theorem, in right triangle OAB by Pythagoras theorem, x square plus y square equal to 100. Now see on the screen. Differentiating with respect to t and so on. differentiating with respect to t. Uh, Ananti is asking x equal to 6. No, Ananti. See, what is asked? We are asked to find how fast the top of the ladder is sliding when the bottom is 6 meter away from the wall. So initially, we cannot take x equal to 6. Now we will say we are given this, we are given that, x equal to this. So what is y? But in general, x and y are associated by which relation? X square plus y square equal to 100. Okay. Now, the next step, what is dx dt? Values are given. Here, dx dt is given to be what? 1.2 meter per second. 1.2 meter per second. Okay. Now, uh, x equal to 6. Now we have to consider when x equal to 6, what is y or what is y square? It is 100 minus 36, that is 64. So y equal to 8, and therefore I will write dy dt equal to, substitute the values, minus x upon y. So minus 6 upon 8 into what? Into 1.2. So tell me, what is the answer? It is minus 0.9. Now why negative answer? Because it is sliding down. That is why answer is negative. But when you write the final answer, you have to say that top of the ladder is sliding down at what rate? Now you need not write minus because we have used the word sliding. So sliding down at the rate point 0.9 meter per second. Okay, right on. Archit, how come 1.6? Why 1.6? I didn't get you. Archit? Okay. Now the next application of derivative is approximation. Now tell me, what is f dash of a? F dash of a is limit h tends to 0, f of a plus h minus fa upon h. Do you agree with me? This is nothing but f dash of a. Now, if h is very small, if h is very small, almost 0, in that case, I can say f of a plus h minus f of a is approximately equal to f dash of a. See, I'm not writing equal to. I should not. I cannot, because limiting value is f dash of a. But I can say if h is very small, almost 0, then f of a plus h minus f of a upon h is approximately f dash of a. Now, if you cross multiply, see what you get. F of a plus h minus f of a is approximately equal to h into f dash of a. Now rearrange the terms to get formula for approximation. So what is that formula? The formula for approximation is f of a plus h. F of a plus h is approximately equal to f of a plus h into f dash of a. Okay. So write down, give the title approximations. I'll explain the proof once again. Give the title approximations. In that, write the formula for approximation is the formula for approximation is write down this f of a plus h approximately f of a plus h f dash of a, h into f dash of a. Now approximation is better and better if we consider h smaller and smaller. Okay, I'll explain the logic once again. See, from the first principles, what is f dash of a? It is value of this limit. But if h is very small, then this I can say approximately equal to f dash of a. Cross multiply. So f of a plus h minus fa is h into f dash of a. Rearrange the terms. So f of a plus h minus fa is h f dash of a. That is f of a plus h is approximately what? F of a plus h into f dash of a. Okay.